Hey, it's Pavel. In this video, I will show you how to use AWS S3 and DynamoDB with Golang. We have a base of our sample raw application, which was built in a bunch of previous videos in this series, and we will add support of one more provider, uh, which goes with cloud. What do we need for it? We will work with AWS SDK version 2 for Go, which I have already installed, and I will show you how to connect to AWS and how to use S3 and DynamoDB to store some data. So let's start with the client. So something that we will need to use S3 and to use for S3 and DynamoDB connections. As mentioned, so we use AWS SDK Draw version 2 for it. There is also AWS SDK Draw package, but the version 2 seems more user-friendly, and so I have decided to work with this one. Also, it's newer, so I think it might be good idea to stick with new and possibly less buggy stuff. So just as before, we need to create some instances for our clients. They will be singleton types. I won't get into details of that, as we have already gone through it in the previous ones. To create a general connection with AWS, we need something like what we see on the screen now. I have implemented two options for authentication. There are a few more, but I have decided not to get too deep into the details. In each case, we need a region defined in which our S3 or our DynamoDB will be available. And here we can authenticate either by a AWS profile, so configuration that is placed on our home directory in that AWS/configuration file, and that profile can be used here to let the application read the data and connect to our chosen AWS config. Also, we can provide environment variables with secret and some credential session, which also in a bit more manual way. So without such a file configured, will let us get into AWS for S3 for Dynamo. Here we can see that very standard building of S3 client on that connection that we prepared above. It will create an instance of client for communication with S3. In a moment, I will show you how to actually use it from Go source code. And for DynamoDB, here we have quite the same with a bit different package. As above, we use S3 service. Here we use a DynamoDB service. It also produces a client which will be used from our provider. So let's get to providers. Here, as before, we need to add one more entry, one space for AWS free bucket, and we need to implement it, of course. So we have the template of such a provider, we need to implement all the functions that we want to use. I won't get through all of them because it may take some time, and I will copy most of the code with some general information of what's actually happening. For the record, we use DynamoDB for holding the metadata of our entries, and S3 for holding storing the content of files. So let's implement a few of functions like obtaining all the entries from DynamoDB. We need to pass pagination, of course, as it's the same schema as with other providers. And we return that paginated resource or some error. And how do we handle this connection? We have that client available. I will probably need to adjust the dependency to import. So let's add this line by hand. Is that helper service for AWS, and having this included on our DynamoDB client, we call a scan function, which needs context included. From what I have found, basically we use to do if we aren't sure what kind of context we are supposed to be using. It is some default which should work. And for the operation of scanning, we need to add scan input, in which we define the name of the table with which we will work. We have it configured in our provider. It has some environment variable as the value of this table. Having that, we need to handle the error, of course. In this case, we will return that null entry. And in case of we have a success here, and then we will parse the resources that we have obtained. So we build an empty list, a slice actually, and for each of the items that we have managed to obtain from DynamoDB, we will call a resource function that I will put here in a second. And with the result, if it works well, so we obtain some result, we append the resources with that new item. And the parse resource, let me just copy it not to waste much time. Probably I have misspelled something somewhere here. And I need one more function about which I have forgot. Let me just fix this. Yes, I have added one more function here to easier parse the UID from string. It's usable for this use case. And what's happened here? We from DynamoDB we get a map of attribute value types. From that map, we can obtain some data like ID of our item, the creation date or modification date, and we build our final structure from what we managed to parse from here. It finally should produce a resource that we can use with our designated response. What else I have put here? I also, as we have a pagination, we need to handle that. So let me just copy it and explain. We sort that result list, for example, by ID. And this that all in general could be basically extended to actually support some filtering or ordering. For now, it's not supported, but I suppose it will. And we obtained the total number of items, and just as before, we built the slice that we will put in our result based on the boundaries that we put in pagination request. That's basically it for the tool. It should let us obtain and desired amount of entries from DynamoDB. As for the obtaining a single item, as it's even simpler, we won't call scan, but actually get item as we know the ID, which we need to pass to our function. We build a key, as that key will be used in our request. And this key will hold the value of ID, and we will put it in the request to get the actual item by this ID. Attribute value member S means that we put a string, and if our result item is found, then we call that item with the same context as before, obviously, and we need to add input, which is that item input in this case. Here also we will need a table name to let DynamoDB know which table is supposed to be used. We can have multiple one defined, and we need to pass this key that we have created above. If there is some error, then of course we return that error. And if everything is fine, or rather, if there is no error, but we fail to get the ID, which means the item wasn't found in our request, then we return that no such item was found. This one here is a custom error that we will define now. So let's add a handler for this one. It's a one-liner that just calls the error fatal with the defined message. And as we got through the error traces, we still have a happy path to cover. And here we return parse results with that item and no error. That would be for getting stuff from DynamoDB. Let's work with S3 as well. We might want to download the actual file from DynamoDB, from S3, sorry. We need also to pass a string here. And we will get the byte array with our content as the resource. For this operation, we will need some buffer. To which we will hold, we will store a temporary result. And from the manager, the manager package is that S3 wrapper to make our work with S3 a bit easier. We put a client as an input parameter, and we can call a download or upload or something like that function. We pass context as in every request here. We pass that buffer, and from S3 package we need that object input structure, and here we will define the budget with which we want to work, and we need to pass key, which is the ID of the item that we want to download. And as previously, we need to handle some responses. So in case of error, Smithy is another tool for AWS to parse their errors. And if there is no error, then we return that byte array with the content of our file. Let's quickly get through the other functions that we would need to implement to make this provider complete. I will just paste the code and explain shortly. To upload the content that we might want to download later, we do a quite simple operation of using the same manager as for the content, but we call a new uploader and upload function, and in the object input structure we include the body, which is a byte array of our file, the same button name and some ID for which we want to upload the content. Then we have three order of CRUD methods, which are create a new metadata item. For that, we need to obviously create some ID, and we build a map with ID read date and modification date, which should be null in this case to hold the metadata. Having such a map built on a DynamoDB client, we call a put item function, and we just define the table name and the item that we have built in this map form. Quite similar will be update, which also we do almost the same. So we build some map with data, and we also call put. The difference, only difference is that we don't generate the ID, but we firstly we try to get the item by ID to check if it exists, and as we put item on the same ID, then it is updated, not created as new. And the last one will be deletion of item, which is also just a single call to delete item on DynamoDB client with past table name and key with ID. That would be all for today. What we did was to build CRUD operations on DynamoDB and S3 AWS clients. It's quite simple for code. There is pretty nice SDK available with a lot of other functions like using some multipart or such to upload or upload items. I hope that it is useful and it shows at least a glimpse of possibilities of growing this SDK. So thank you for the attention, and feel welcome to check other of my videos.